Substituting k is equal to minus 1 over 5 into the differential equation. This is the differential equation that we have gotten, and we are supposed to solve this differential equation. According to what we have discussed in our topical outline, this kind of differential equation is the second type, okay, and we are supposed to re-express it as a variable separable format in order for us to solve it. Okay, this is already in the variable separable format. The next thing that we need to do is to bring the x portion over to the dx, dt side. So dividing this over, I'm going to be getting a 1 over 1 plus x minus x square is multiplied by dx dt is equal to minus 1 over 5. And this is the kind of condition that we are looking out for in order for us to integrate both the left and right hand side with respect to the term that is below here with respect to t. So integrating the left hand side with respect to t, I'm going to have 1 over 1 plus x minus x square of dx is equal to minus 1 over 5 integration of 1 dt. So integration of dt. And the hint that is given to us by the question is we are supposed to make use of completing the square. So I'm going to complete the square for this expression over here. Completing the square for this, it is first I'm going to factorize out minus 1. So it will be x squared minus x minus 1 dx is equal to minus 1 over 5 integration of dt. And this is integration of 1 over minus x minus half square minus away half square minus 1. Where this of dx is equal to minus 1 over 5 integration of dt. Where this is minus 1 over 4 minus 1, so together it is minus 5 over 4. So if I were to multiply the negative 1 back in, it is going to be 1 over 5 over 4 minus x minus 1 over 2 square of dx. This is minus 1 over 5 integration of dt. For the right hand side, it is pretty easy to integrate because it is just 1. For the left hand side over here, I'm going to make use of what I have in my formula sheet, the integral of 1 over a square minus x square. And to apply that here, I'm going to add on to it, the fx f prime x kind of differentiation, because this is going to be my fx and f prime x happen to be a convenient value of 1, which is always going to be here. So let me re-express this. I'm going to re-express this as integration of 1 over square root of 5 over 4. So square root of 5 over 4 square minus away this, which is this over 2 square of dx is equal to minus 1 over 5 integration of dt. Wait, this is square root of 5 over 2. So using the formula in my formula sheet, it is going to be 1 over 2 times of this, which is square root of 5 over 2. So square root of 5 over 2 ln of modulus of this square root of 5 over 2. So square root of 5 over 2 plus what I have here. What I have here, this is going to be x minus 1 over 2 divided by square root of 5 over 2 minus x minus 1 over 2. Modulus of this is minus 1 over 5t plus an arbitrary constant. I'm going to make use of a. Actually, if you were to look at the question says that x is always going to be between 0 and half. Which makes the numerator positive and the denominator positive. Okay, anyway, if you have managed to observe this, you can actually use a curved bracket instead of the modulus. But even if you have not managed to observe this, leaving it in with this modulus is totally fine. Okay, but since we have talked about it, I'm going to remove the modulus. I'm going to simplify this. This is just 1 over square root of 5 of ln. I'm going to use a curved bracket. And I'm going to multiply by 2 on top and 2 below so that I can remove this 2 and this 2. Okay, so it is going to be square root of 5 plus 2x minus 1 divided by square root of 5 minus 2x plus 1. This is minus 1 over 5t plus a. Since the question wants me to make to find t in terms of x, okay, let's make t the subject. Bring a over to the other side. It is going to be minus 1 over 5t is equal to minus a plus 1 over square root of 5 ln of square root of 5 plus 2x minus 1 over square root of 5 minus 2x plus 1. multiplying minus 1 over 5 over to the other side, t is going to be positive 5a, I'm going to call it as b. Then multiplying this over minus 5 over square root of 5, it is just simply minus square root of 5. Then ln of square root of 5 plus 2x minus 1 divided by square root of 5 minus 2x plus 1. It is such a long question, and in fact we have not even ended, okay, because the question actually gave us enough information for us to solve for b. The question says that when t is equal to 0, x is equal to half. I'm going to substitute that in. So when t is equal to 0, x is equal to half, which means that 0 is going to be b minus square root of 5 ln of, substituting x as half into here, it is going to be 1 minus 1 and minus 1 plus 1, so it is square root of 5 over square root of 5, which is 1, and ln 1 is 0, that is why b is equal to 0. We're replacing b here by 0, that means t is going to be minus square root of 5 ln of square root of 5 plus 2x minus 1 divided by square root of 5 minus 2x plus 1. Let's move this negative up as the power here. So t is equal to square root of 5 ln of square root of 5 plus 2x minus 1 over square root of 5 minus 2x plus 1, the whole thing to the power of minus 1. So I can remove the minus 1 by, reciprocally, doing a reciprocal to this. So t is going to be square root of 5 ln of square root of 5 minus 2x plus 1 divided by square root of 5 plus 2x minus 1.